Hi everyone, welcome back. We are in Module 2. We are in Topic 1. We are in Lesson 5. And we're just going to kind of get the lesson started here. Our key term this time around is linear relationship. And we've talked about this word already this year. It has the word line in it. So we're going to focus on that here in just a little bit. Learning goals: plot ratios and equivalent ratios on a coordinate plane. Read equivalent ratios from graphs. Use ratio reasoning to determine equivalent ratios from graphs. Recognize the graphical representation of equivalent ratios. Quick review: a tree grows at a constant rate of 3 feet per year. Write a ratio to represent the amount of growth in feet to the number of months. So growth in feet is 3 feet. Now notice this says 3 feet per 1 year, but this says per number of months. So we need to do 3 feet to 12 months. So you have to be careful that you're understanding the way the information is given and then the way the question is actually being asked. Okay, it says number 2, create a double number line that describes the growth of the tree every 12 months over a 48-month period. So we learn here at 3 feet, it's 12 months. 12 months, 3 feet. So 12 months, it's 3 feet. So then every 12 months, it's going to be an additional 3 feet. So at 24, then it's 6 feet. At 36, it is 9 feet. And at 48, it is 12 feet. Okay. And we are going to keep on going here. We're only 2 minutes into this. This is page 223. I'm skipping the getting started and the activity. And I'm also skipping this activity 2. I talked about this in the last video where I think these dotted lines, although it can show us where to put the dots, I think it leaves a lot on the graph. And I think that's a bit confusing for some if we just use the edge of our index card. And even if we kind of highlight the edge of our index card kind of the entire way, let me just do this here. It would be more helpful to see where we are lining things up. So it would then be something like this. So that might be easier than having all of the dots. If you can line it up like that and then just place the dot. So I will ask if we can fill in this data right here. Even though we haven't gone over all of what this was about, we can still use this data table here to figure this out. So it says you've used tables and double number lines to represent equivalent ratios. Let's investigate how you can use a graph to determine other equivalent ratios and understand the connections between the representations. So this is on page 227. Okay, page 227. Ava creates more rectangles that maintain the same ratio of side lengths. The table shows the lengths of the sides and set of the rectangles. So that goes back to previous activity right here, which was to cut out all of these rectangles. But we're not going to do that. But I do want to look at this, like the short side in relation to the long side. So does it have the same ratio consistent throughout? So notice, and remember I told you in class, a table really is, it's a double number line. A double number line is the same as the table. So 2 units on the short side matched up with 5 units on the long. And you can look at those rectangles on page 239 if you want. Okay, so 4 match up with 10, 6, 15, 8, 20, 10, 25, 14, 35. So it looks like they have the table represented here well. So what number is missing? What are we going up by here on these intervals? it looks like we're going up by 2. So I'm going to fill this out, but then we're going to verify it. And down here, it looks like we're going up by 5s. Okay, so how can I go, let's say, from 2 to 12 times 6? Am I also at a times 6 here? Yes, I am. Okay, I think that's all I really want to show you on that page. And we are going to then move over to page 230, activity 3. So this is page 230 in module 2, topic 1. Use ratio graphs to solve problems. You know different ways to think about ratios, so you can use different strategies to solve problems. The graph shown represents the number of gallons of water used for the number of times the toilet is flushed. I know y'all love talking about that, don't you? If you're listening to this, I don't know, give me like some water droplets or something here on the page. I just want to know that you are listening to me right now. Maybe write the chemical symbol for water, H2O, and some water droplets. That will be fun. Okay. Write each point on the graph as the ratio of gallons of water used to number of flushes. So we have water used here and flushes here. So this is our y-axis, this is our x, it's labeled. So water used for each of these. So we need to figure out how this graph is being laid out. So from 0 to 5, we have 1, 2, 3, 4, 5 intervals. So if there's 5 intervals between 0 and 5, obviously this counts up by 1s. And it looks like the same here. So going by 1s. So this first dot then, gallons of water used, it looks like it's 3 gallons of water to 1 flush. 3 gallons to 1 flush. I could also write that as 3 gallons over 1 flush. The next one is, let's see if it's going up by 1. That's going to be 6 and 2. 6 gallons to 2 flushes. 6 gallons, 2 flushes. Go ahead and pause and finish this out, please. Nine gallons, 3 flushes. And then 11, 12, and 4. Oh, I put FL for flushes, I guess. I'll just write that one out. So 12 to 4. It says, what do you notice about each ratio? Are they equivalent ratios? And how do we know? So remember we talked about an equivalent ratio. If I did, this is already in a unit rate. This is a per 1, so 3 gallons per 1 flush. What is 6 gallons for 2 flushes? What is that as a unit rate? So what is the 6 divided by 2? That gives us a unit rate of 3 gallons to 1 flush. What about 9 gallons over 3 flushes? So 9 divided by 3. Again, that's 3 gallons to 1 flush. 12 gallons to 4 flushes. Again, that is 3 to 1. So each ratio is equivalent to 3 gallons to 1 flush. How many gallons of water would you use if you flushed the toilet 8 times? So we don't have the 8 on here, and if we did, like the 8 is here, obviously, for flushes, 6, 7, 8, but I don't see it anywhere on here. And if I filled this out, I extended this. Now for these ratios to be equivalent ratios, it has to go through this origin. But the 8, like, I don't know. Like, I don't have it labeled way up here. So I'm going to have to use the ratios. I can't talk. Words are hard to figure this out. So let's do the 3 gallons for every 1 flush. And now it's asking us how many gallons for 8 times of flushing. So 8. So how do you go from 1 to 8? Times 8. So 3 times 8 is going to give us 24 gallons. You may not have used the 3 gallons. You might have used the 12 gallons for 4 flushes. And it says explain the method you use. So maybe you did 12 gallons for 4 flushes. And then you saw the 8 flushes here and saw that you could do a times 2 times 2. You're still getting the 24 gallons. Letter D. How many times would you flush the toilet to use 18 gallons of water? So let's go back to our 3 gallons for every 1 flush. But now we're told 18 gallons is how many flushes? So we're questioning for the flushes. And we're being told 18 gallons. So how do you go from 3 to 18? Right, times 6. And then we're going to do a times 6 here. So we have 6 flushes for 18 gallons. So then did you use the same method? Could we use the graph on either of these? 6 flushes. We're still off the graph. Okay. And let's move on here. That was 230, so we are moving over here to 231. Okay, so it says the graph shown represents the number of gallons water is used for the number of loads of laundry now. Write each point on the graph as the ratio of gallons of water used to number of loads of laundry. So water used to loads of laundry. So let's see, we are going up by ones here. Here we have 1, 2, 3, 4, 5 intervals between 0 and 10. So 10 divided by 5 is 2. These are counting up by 2s. So here's 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, and 42. Okay, so we have 18 gallons to 2 loads of laundry. And then the next dot is halfway between 26 and 28. So we have 27 gallons. And let's see, let me just make sure I have this correct. It's at 3 to 3 loads of laundry. And then the last one looks like it's at 36 and 4. So 36 gallons to 4 loads of laundry. So what do you notice about each ratio here? So for this one, I notice that each ratio has the equivalent of what? if I divide 18 by 2, it looks like I'm getting 9 gallons for one load. 27 divided by 3 is 9, so 9 gallons for every one load. 36 divided by 4 is 9 gallons for every one load. Now, when they have the ratio written like this with the colon, we can certainly write it like that. So 18 gallons to 2 loads. We can say 27 gallons to 3 loads and 36 gallons to 4 loads. We can still show the per one load, and per one load. So how do you go from 2 to 1? Divide by 2. So 18 divided by 2 gives us the 9 gallons. 3 to 1 is a divide by 3. So 27 divided by 3 gives you the 9. 4 to the 1 is divide by 4. 36 divided by 4 is 9. So we're still at the 9 to 1 ratio. So what do we notice about each one? Each ratio is the equivalent. So each ratio is equivalent to 9 gallons of water to 1 load of laundry. How many gallons of water would you use for 7 loads of laundry? So 7. So if we have 9 gallons for 1 load and we want 7 loads of laundry, how do we go from 1 to 7? It is a times 7. So 9 times 7 is going to give us 63 gallons. How many loads of laundry can you do if you use 45 gallons of water? So 45. Notice they're giving us numbers that are not on the graph. So let's stick with our 9 gallons for 1 load. And now it's going to give us 45 gallons. How do we go from 9 to 45? Times 5. So 1 times 5 is going to give us 5 loads. So did you use the same method? Why or why not? If you have another way to do that, please write it down and share it with me, and we'll share it with the class. Like maybe some of you used division too, because I know when the graph tells me 9 gallons of water are used per load, when I know the number of loads, like here, when you know the number of loads, you can multiply by 7. When I know the gallons, so what could we do here too? Like if we know the gallons, I'm sorry, not by 7, by 9. Make that a 9, please. I saw that 7. It is a 9. So when you know the number of gallons, when you know the number of gallons, you can divide by 9. So we knew 45 gallons. 45 divided by 9 gives us the 5. Here we had 9 times 7, or the number of loads, 7 times 9 equals 63. Okay, moving on. One last page here for activity 3. Augie burns 225 calories for every 30 minutes he rides his bike. Page 232. Complete the table to the chart. Complete the table to chart the number of calories burned for different amounts of time, then plot the values on the graph. So I know some of you are going to look right at this table and say, I don't know, I don't have any numbers up here. A lot of you are doing this in Mathia. You have to read the given information. Augie burns 225 calories for every 30 minutes he rides his bike. So here at the 30, we know the 225 calories burned goes with it. How do I know that? It gives it to me up there in the blue box. Okay, so then we have to fill out the rest of it. Well, how do you go from 30 to 10? We could divide by 3. So here we're going to divide by 3. What is 225 divided by 3? 75. Now, from here, you could go from 10 to 60. You could go from 30 to 60. It doesn't matter, whichever you want to do. If I go from 30 to 60, I'm doubling, right? I'm doing a times 2. So then here I would be doing a times 2. 225 times 2 is easy. That's 450. Okay, so how do you go to 50? Let's go from 10. Like 10 to 50 is a times 5. So 75 times 5. So 75 times 5. If you don't know, write it out like this, or grab yourself a calculator. 5 times 5 is 25. For the 5, carry a 2. 5 times 7 is 35, plus 2 is 37. So 375. And now we're supposed to graph it. Calories burned is 225. The time in minutes is 30. Okay, so this is our y here, and this is our x. So our ordered pair then for this one is 30, 225. So go over to 30. Where's 225? How's this broken up? Well, our interval goes from 0 to 100, and 1, 2, 3, 4 intervals in that space. So 100 divided by 4 means it's going up by 25s. So if it's going up by 25s, I'm just going to put the 50s in there. So we are looking for 225. So 225 is going to be halfway between the 200 and the 250. So 225, and we need to put it at 30. 225 and 30 means our dot goes right here. 75 and 10. So 75 is here, and our 10, 75 and 10. 450 and 60. So here's the 450. We're going to follow that straight across here for the 60. So am I in the right spot? 450 is this one, and 60. So we're right here, right where that is pointing, like right there. That kind of creates your like little arrow on where you're putting your dot. And then 375 and 50. So 375 is going to be right here. And here's the 50. So right there is where my dot's going to go. And then I can connect my dots. Make sure you go through the origin. I might actually do it this way because I can kind of use the stickiness and hook it down. Okay. How many minutes would Augie have to bike to burn 150 calories? So 150 calories is here. Let's do this. So over to 150, and then the 150 and the orange line are right here. So it is about 20 minutes. About how many calories can he burn if he bikes for 25 minutes? So 25 is here, and that goes up to here. And when we follow that across, it looks like it's coming across right here. So wait, 25. Is that right? 25. It looks like 175. I'm going to pause for just a moment. Okay, my apologies. All right, so 25 minutes. So when I go over to the 25 minutes, when you first look at it, it looks like it crosses right here, but like my line is down just a little bit too low. It's actually coming up at about right here. So that's somewhere between the 175 and the 200. If I set it up with the proportion, let's say I do the 75 calories in 10 minutes, and it's asking me for 25 minutes. How do you go from 10 to 25? Multiply by 2.5. So what's 75 times 2.5? So if you don't know, let's do this. So 75 times 2.5, 187.5. So, and that seems about right. It's between the 175 and the 200. So 187.5 calories. How was the graph helpful? Were there any limitations when using the graph to determine the values? So it's helpful to visually see how his calories change over time. The part where it's difficult and there's limitations is this space right here between the 150 and the 200, and even between the 175 and 200 is so small that I can't get an exact number. So if I want exact numbers, then I would need to have more intervals between. So there are limitations. Because you, how do I want to say this? Let's just say you cannot read some of the exact values because of small oh, I don't know. I don't know how I want to say this. Because of small it's really like small spaces between large numbers. Like we should have more intervals spacing this out between those large numbers. Right? Even here, like if we counted up by twos, it might make it better. If we counted this up by tens, it might make it better. We have such a small little space for a large amount of numbers. There's 25 numbers in between each line. That's a small space for a large amount of numbers. Okay, and we will see you on the next video.